Okay. All right. So before the connection broke, we were discussing about the role of zookeeper in case of HBase. Okay. So first, a few things. So zookeeper is not only used by HBase, but there are lots of services which require zookeeper. So zookeeper is this third party and which acts like a coordinator, which acts like you have seen a hotel reception where all the visitors keep on telling that I'm here in case somebody comes searching for me, just inform me, and so on. So zookeeper is like a coordination service which makes sure that which makes sure that people are able to coordinate and there is no corruption in the data during coordination. And that is main role of zookeeper. You will understand it as we go forward. So you can think of it this way. When we have multi-threaded systems, we had some constructs like monitor, like semaphores, and all of those for coordination. But But when it comes to multiple machines, say your program is running on multiple machines, they need to coordinate with each other. So they require a central service, and that central service itself has to be really, really robust. And that's what is Zookeeper. All right. Now, Manish has a question. And one thing with respect to replication, do we have multiple copies lying on different region servers connected to HDFS? Yes. So every region that is being saved onto HDFS will automatically be backed up uh, into the other replicas. Okay, so Srinivas, I did not get your question. So my doubt is Zookeeper not in Hive, but it is key role in HBase. Yes. So in case of Hive, Hive was not doing much. Hive was just basically taking your query, converting into MapReduce, and getting it done by Hadoop, getting the MapReduce executed on multiple nodes by Hadoop, and that's all. So Hive did not require much of a coordination. The only thing extra it did was storing the meta store, storing the storing whatever tables you have created, whatever views you have created, so that you don't have to create them again. And that was the role Hive was playing. Okay, and so Hive did not require any explicit coordination because say you are executing a Hive job and I'm executing a Hive job. Internally, the only conflict that could occur is between while we are reading the metadata of a table from the database, from the meta store, right? And that is anyway a single, it's based on normal RDP mesh, so there is no chance of conflict. And say the other thing is when I am executing a job and you are executing a job on the same Hadoop, Hadoop internally takes care of segregating my data from your data. Okay. So Srinivas' question is, as per my understanding, to manage the H file mem store. No, H file mem store and write ahead log is basically the duty of regions. So you will understand Zookeeper when we go ahead. Say you have 500 region servers, 500 machines running region servers, out of which region servers are alive and which region servers are dead. This information to master should be given how? Okay. So there is a master who needs to know how many region servers are up and how many region servers are down. Now, if master starts If master starts pinging to all the machines simultaneously, all the region servers it starts pinging, so what will happen is master will be too busy and that will be very inefficient. And those kind of complications are handled by Zookeeper. So region servers, as soon as a machine turns on, region server is updated saying I am up. Okay. And whenever master needs, master can ask how many region servers are there. Master can ask this question to Zookeeper and Zookeeper can answer. So that's the role of Zookeeper. Okay. So this coordination between master and region server, and similar coordination is required at name node and data node level. So there also HA, something called highly available setup, includes Zookeeper. So if a name node wants to know which all data nodes are dead and which all data nodes are up, it will ask Zookeeper, and Zookeeper will know that because all the data nodes will keep on informing Zookeeper. Probably, I think I should move Zookeeper session to maybe before, just after HDFS, because Zookeeper is something which is going to be used in multiple machines. All right, multiple systems it is used. So we talked about data model last time, and we also, so we were here, right? We talked about what is the column or cell. All right. So So in HA case, no, data node does not ping name node directly. Okay. Data node will keep informing the Zookeeper, and Zookeeper will keep track of which all data node are up and down, and name node will keep on asking Zookeeper. That's correct, yeah. And the HA case also, you have name node and backup name node. So the moment name node goes down, backup name node takes the place, and this information is retained at Zookeeper level. When data nodes, when people are asking for who is the name node, who is the name node, they will ask Zookeeper. So whenever users are asking for which one is our name node, so Zookeeper will give them the name of the current name node. Okay. So this is switching between name node and backup name node will happen at the level of Zookeeper. Okay. Are you able to hear me clearly? All right. Now, so can anybody help me recollect where we were till last time? So we were here on this slide. All right. So we basically were here. All right. So we discussed last time that what is a big table or what is the HBase, the data model. And data model is something which we need to understand. So part of the data model, first of all, is table. A table is it's basically the usual table, whatever we have understood so far. Just to keep in mind the table. So one thing is that almost everything can be used as data storage in HBase. Say column names, row names, and so you everywhere you can store the binary data, except for few things. One is table name can be plain text strings, with which you can create a name. So a slash cannot be in the table name. Then comes row. Within each table, data is stored in a row. We all know this part probably, right? And So these are basically HBase is a tabular representation of data. It has rows, and each row, the different thing from the traditional rows, each row has to have mandatorily a key, which is called row ID. Okay? Each row is identified by a row ID. Alright? And row keys do not have a data type and are treated as byte array, meaning row key can have anything. You want to put them a movie, row key can have that. Okay, so inside row key you can put anything. Then there is something called column family. So instead of having columns directly in the full table, we create column families. So table has columns, sorry, table has column family and column family has columns. Okay? So a column family is basically multiple columns together. In a column family, we can keep adding more and more columns, but we cannot add column family into table as and when we want. We have to we have to describe that this is the column family while creating the table. So while creating the table, the only thing that is mandatory is to define at least one column family. Also, we cannot add column families later point of time into a table. Okay. So the role of a column family is, as I told you, that HBase is a column family oriented database. What does it mean? The data in a column family tends to be stored together. Okay. So if you have a pattern where you have to access some values in a single sort very commonly, then store them, make those columns as one column family. For example, first name and last name and title. The chances are the title, first name and last name, or salutation, first name, last name, these three columns will be accessed together frequently. And therefore, it makes sense to make these three columns as a column family. Okay, so that is why you should make sure that the data which you want to access frequently, you put that in a single column family. Okay. Now each row in a table can have different columns but same column family. Okay. Although the row does not need to store data in the all column families, but all rows have same column families. Alright. And similar to tables, the name of column family should be plain text, should be something with which we can create a file in the file system. Okay. Reason being that with the name of column family, it in under the hood creates the file and the folder in the HDFS. So you will understand, Manish. Just give a little bit of time, and we will go through this thing. All right. Now, so we talked about few things. There is a table. Table has column family, and column family has columns. Okay. Column or column qualifier. Okay. And traditionally, we had always been thinking that column names should be something where which are defined upfront while defining a table, but in case of HBase, that is not true. Okay. The way we keep on adding rows, similarly, we will be adding more and more columns into a column family. Okay. Also, the way we could store binary data into the row ID. Similarly, we can store the binary data into the column ID. Okay. So column name itself can be a storage for you. Okay. Okay. So you can have things like, let's say you have a movie, it has got a video track and it has got an audio track and it has got a subtitle. All right. So you can basically have things like store the video into the row ID, audio into the column ID, and the subtitles into the cell. And what is a cell? Cell is the basically cell is the value where we put the data. Okay. Cell is the one which is identified. So as a visualization, this is the visualization. So you have table. Table is containing a column family. There is a column family called personal and there is column family called office. Okay. Okay, let me just go through these buzzwords and then I'll discuss point 3 and 4. So you have got column family office and personal. Column family personal has a name of column, name column, residence for phone column, and in office there is phone and address. These are columns, and this is the column header or the column identifier. This is the row header or row identifier, and here this is the cell. Okay. Now each cell has got something called version. Okay. So each cell can also have multiple values tagged by something called a version. By default, the version is timestamp. If you do not specify the version name while writing the data into cell, the current time is used. If not specified in read, the latest value will be returned to you. Okay. And number of versions by default is 3. Okay. And you can change that whenever you can change that while at the time of table creation. Okay, now going back to the version means each cell has got 3 values. Okay, not like a file replica. It has got 3 values. So whenever you are putting the value, like in your traditional, if you have designed a temporal system, how many of you have heard about temporal system? So what we used to do in traditional case was that we had a table, and whenever we are writing a value into a cell, we have a table. Whenever we are writing a value into a cell, uh, or value into a table, what would we do is we'll keep the backup of the table. Okay, we'll keep the backup of this particular value so that in future if need arises we can revert back to the previous value. All right, and that's what is the versions. Now coming back to Basurazi's question, point number 3, column qualifier do not need to be consistent between the rows. Yes. So some rows can have some columns while other rows can have other columns. That is something very different from what we have always studied in RDBMS. Okay. So as we said, that is more like a hash table. So some rows can have some column while other rows can have some other column, and if they want to keep all the columns same, it's up to them. All right. This will make the whole table sparse, but that is okay with HBase. All right. So you meant this one. And what you wanted, they must be defined upfront and not easily modifiable. Okay, just like we used to define columns in our traditional table, where column cannot be added so easily later on, and column need to be defined upfront. Okay, so in the same way, in case of HBase, the column family needs to be defined upfront. And every row has same set of families. Okay, the behavior of column family is like columns in our relational database. Make sense to you, Basuraj, now? Great. Moving on. Any questions on column family, column qualifier, cell value, row ID, version name? Okay, this diagram will make it clear. So imagine that you have this phone book. This phone book has got two column families. One is personal. You can see this. These two columns lie in the personal column family. And we have another column family called office. Although here all the values are fully filled and it's not a sparse table, but still it'll give you a idea about what is a column family and what are the various definitions. These are column identifier: name, residence, phone. All right, and at a later point of time, the way you keep on adding the rows, similar way you can keep on adding the columns into column family. And the, that's why we say that HBase does not have much of a differentiation between the behavior of rows and behavior of columns. The behavior of rows and columns are same. You can keep on adding rows as well as you can keep on adding columns, and you can keep on adding. Each row has header, and each column has a header. Both row header and column header can also store binary data, while cell can also store the binary data. Okay, while column family name and the table name, we have to have a plain text in them. Column qualifier in this is name, residence home, residence phone, phone, and address. So there are four columns and four column qualifiers, meaning column name. Column name is the column qualifier. That's how we are pronouncing it. All right. So in another way we can say that there is a table called here, the phone book. There is a table. We call this table, let's say, 0001. This table has got office, which is a column family, and column family office has got address and phone. Those are the column qualifiers, and address and phone each have for each timestamp the values of various things. Okay, sorry, here there is a 0001 is the row number. This is the 0001 is the row number, row key. Each row key has got two column family. First column family has these column values, and second column family has those column values. This is how you can look at it. Alright, so probably this example what we are going to talk about is the most important one when it comes to the architecture or the data model. Alright, alright. So how have you ever imagined that? So so how many of you know that how does Google search work? Quickly, just two paragraph, two sentences. Just two sentences will be good enough. We all understand that, right? We all understand that Google crawls the data and stores it somewhere. It downloads all the websites and it is stored somewhere, right? Okay. So Google basically downloads the data from all the website across the world and it stores it in a database. Now you can imagine that such kind of database would be how big? Okay. The plain text only data is around 500 terabytes as per the last crawl corpus of Amazon. So it is around 500 terabytes. Sounds small because it's just 501 terabyte hard disk. But when you try to handle such kind of data, it becomes almost impossible using the existing tools. Alright, so for that kind of database, they needed to do a lot of churning, a very complex churning. The complex churning was similar to our fourth example in the first exercise, the voting problem. So in case of website, what they do is one page is voting to another, okay, and one page is voting to another and making basically a graph of who is voting to who, and based on the value of the voters, the value of votee is decided, and this votee might be voting other people and their values is decided this recursively. Okay, so I voted for you, your value got high, and then you voted for somebody, their value got higher, and so on. So people who are being voted by the most value people, high value people, they get the better value. Okay, rather than simple count of the vote count, they are using this recursive definition of voting. Okay, so that way that way Google is able to form a graph. That's a first algorithm called PageRank. Okay, so PageRank basically makes sure that the documents which are being referred by more people are more valuable, and if these documents refer to somebody else, that document becomes far more valuable. And that is where the role of big table comes into play. So when they had to store such a humongous data in a well format, they used their big table. And the architecture was like this. In each row, they stored a single page. Also, in each row, they stored who all are linking to this particular page. So, imagine this. This row represents CNN.com's data, right? This row represents the CNN.com's data. It has got all the HTML they downloaded from CNN.com, and then then it has a list of all the URLs who are referring to this particular CNN.com's website. Now you can quickly see that when you download the data from CNN.com, you will only get contents, right? HTML content, PDF content, something else. You will not get these references, right? These references you will discover when you are downloading somebody else's website, right? So the moment they download a website, they also analyze that which all website it's linking to, and then this table, the other rows having those websites is updated. So for example, first they downloaded CNN.com's data and filled in contents. Till then all anchors were empty. Okay, now they downloaded cnnsi.com, and after downloading, when they analyzed the content, they realized that cnnsi.com is referring to cnn.com, and then they update this row in which cnn.com's data is there. Okay, we add one more column in this as and when we encounter a reference to cnn.com. So after some time they crawled mylook.ca. After downloading mylook.ca data, they realized that mylook.ca is having href or a link to cnn.com. So they add one more column here for for this URL. Now you can see that this table represents the crawl corpus. Each row represents a single website. And what does it have? This table has this row containing the data of CNN.com, www.cnn.coms. The key for this row ID is the URL. Okay, www.cnn.com is the key. And then is the content of www.cnn.com. Okay, and then is the backlink, which is the link which are referring to cnn.com from rest from various sources, right? So this is the architecture. Now again, here contents is one column family. The column qualifier in case of this first HTML one is empty. If we wanted to have multiple kinds of content, PDF, MP3 or whatever, we could have multiple columns under content column family. Okay, we could have PDF content, we could have HTML content, we could have MP3 content, and so on, right? Similarly, we could have cnnsi.com, and anchor is a column family containing multiple columns of anchor. Okay, now you can see that cnnsi.com is a column name, while cnnsi.com is only linking to www.cnn.com. Other people may not be linking to it. So you can now, can you visualize that how would this table look like? Any doubts here before I move forward? Not clear? Yeah? Okay. So Basra's question is unable to visualize anchor column family. So anchor column family, okay. Manish, do not visualize in terms of folders and files right now. Okay. That will be a little difficult. Okay. And yeah, I'll help you in that after this one. Try to visualize in terms of a table structure. Okay. And also, think about this table as, hardly 1% filled. Okay. 99% of the table will be empty. Correct, correct. Contents is a column family which will have multiple columns like PDF, images, etc. That's correct. And the default one, the column name, uh, which is empty, is for HTML. Okay, it's also our own choice. We could keep its name as HTML, but we just kept it as a blank just to mark that this is the default format. Okay, or just to give you an example that we can have empty column family. Yeah. Any other questions? Okay. Anchor column family, we can have, say, if there are a million websites pointing to or linking to www.cnn.com, then anchor column family will have a million columns. Okay. If cnnsi.com is pointing to some other website also, then that website, that row will have this column called cnnsi.com, anchor column cnnsi.com. Otherwise, it will not have. Okay, so you can see that anchor column family will be heavily sparsed. Also, the cell value in this case is the name with which they are referring to. So whenever you are creating a href link, or whenever you are linking to some other website, you provide first a link to of the other website to which you want to link, and also the link text. Okay, so link text is what we are keeping in the cell, the text which is displayed to the user, on which the user will click and then you'll go to the URL. So there is link text and link. So link text is what we are keeping in the cell. This basically helps us in identifying with what name people are referring to CNN.com. Okay, this helps us understand with what name each individual website is referring to this. Okay, so this is one example of of using data model of HBase. Now column family, yeah, let me just copy it. I think Srinivas's text got garbled a bit. Let me, okay, just give me a second. Alright, so here we have column family, column family, column family, content, image, PDF, HTML. Yes, 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 that's correct. That is correct. So anchor will be anchor colon URL itself. Okay, and the column name here is actually the URL. Okay, like yeah, like meetup.com. That's very correct. Anchor column, yeah. Or you can say Facebook is linking to our page, or LinkedIn is also linking to our page. So it is that way. So yeah, mm, yeah. In the header itself, the column name itself, we are adding it so that we are using column name as storage for the URL which are linking to us. So it will be anchor colon facebook.com, which is linking to our website, anchor colon some other one. Okay, so for each reference website, will there be one column family? No. So for each referenced website, there will be a column family. No. So for each referenced website, meaning reference as in www.cnn.com, right? So for each website, there will be multiple single column family. All of them will have anchor column family, and another column family would be contents. But under anchor, if there are million URLs which are referring to cnn.com, there will be a million columns will be added. And for each new website which we discover, we will have to add one more column. Yeah, in that sense, you are correct. All right, so I think we all are on the same page. Are we all on the same page? This is very important. If you have any doubts, I can explain it again. Rest of the session, rest of the topics which we may we if you may I mean we can escape, but this part I would like to explain in detail. Okay. Reason being that this is what people expect from you when you try to work on HBase. Okay. Now, other thing is the thing which we have skipped so far is there is one more property. So we one property which we utilized is that we can keep on adding more and more more and more columns as and when we want, right? We as and when we encounter a new website, we add a column with the name of this website so that we can that too if this website is referring to somebody, only then we add a column and we update that. We add this column onto those rows which have that to which our new website is pointing to. Okay. So if we are crawling facebook.com and we encounter that it's referring to million columns, then we add a column called facebook.com and add 1 million values corresponding to each of the website which we being referred. All right. So Anand is okay, Baswaraj is okay with this kind of definition. Kalyan, Lakshmikant, Manish, Surya, Srinivas. Yeah. So except for Baswaraj and Srinivas, nobody's okay. Great, great. So there is one more tiny little point which we need to discuss. You see the row ID here. Okay. So okay. So Kalyan, there's no worry if you are. I mean, I think you came on the fairly early. No, I think you joined late. All right. So here we have row ID, which is not straight away, which is not www.cnn.com. It is com.cnn.ww. All right. So why is it so? Why did they do it that way? So this is a little important part to us. So as we said earlier, that row IDs are sorted, right? As we discussed earlier, that row IDs are sorted. The row IDs are sorted as we discussed earlier. And here, what does it mean by that? So what it means that if we have one website, say xyz.com, and another website is xy.com, these will come together, okay, as opposed to a.xy.com. Okay, so what will happen is that now look at this. So a.xyz.com and then b.com and then a1.com and so on. Why? Because they are sorted. Let me sort this data, and this is how it looks. All right. So you have a website. If we had stored simply like normal one, and we also told you that it's a sorted hash map, right? While we were giving that definition from big table, we told you that the table is ordered by row key. The table is ordered by row key. If we encounter a new row key which is lying between two rows, then it gets inserted. So when we have this table and we encounter a new URL called c.com, it will be inserted here. Okay, so you can imagine that, what do you call it? There is a primary index on this table based on row key, correct? Now imagine that you have to analyze a single website, say xyz.com. So you will have to analyze a.xyz.com as well as normal xyz.com, xyz.com. Okay? So you'll have to analyze these two websites. Now, this website, because this is what a dot means, it's a subdomain of xyz.com, correct? And therefore, we need to analyze both of these domains together as per our use case, because we want to understand who all are ranking, referring to these websites, and how do they lie. Now, you see these two URLs, although they belong to the same website, but they are far apart. They are far, far, far apart. This is not going to work because we want to analyze these together. Therefore, we have to come up with a scheme so that we have to come up with an ID so that the all the subdomains of a website should come together. All the subdomains of a website should come together. And that's where the role of these things come in. So what they have done is, instead of storing it like this, what they have done is they have reversed it. What does it mean by reversing? They have made it com.xyz.a, okay, instead of this, and instead of this they have made it com.a1, and then they have made it, instead of this, com.a. It's not really, reverse string. It's just that order of domains have been switched. Instead of saying c.com, we say com.c, and instead of saying xyz.com, we say com.xyz, and here com.xyz and com.xyz1. Now you see that. Okay, now you can see that when you sort the data, the subdomain and the domain a.xyz.com and xyz.com both have come together. Okay, in their line numbers are just differing by one. Okay, so on fifth line we have xyz.com, on next line it is a.x. So they have come together. Why? Because the subdomain, when you do this kind of, when you reverse the order of the domains, the sub-subdomain become more insignificant, and the top level domain becomes more significant. And therefore, when you basically, that's the reason we have sorted it, so that all the data of our website, all the data of a single website should be in the next rows. So all, when we have to analyze xyz.com, we just have to find a row with the row key called com.xyz, and then we'll keep on going down, right? Yes, this is how DNS also works. Alright, so why did we do that? We are trying to exploit the property of a table that row key is sorted. The whole table, the whole table is sorted by row key, so that we do not have to keep searching again and again for each subdomain, and we don't have to keep track of all the domains of a website separately. And that is where the role of this row ID comes into play. Okay, so in this particular architecture, what all did we exploit? Okay, first we exploited that all the we are keeping we are adding columns as in when we want. That is very different architecture from what you had studied in RDBMS. We will never do it in RDBMS. Instead, we will keep a separate table containing row key and column key, uh, and we'll keep on adding these as row, not as a column. So that's one big difference. Here we are adding columns as in when we are discovering a new. So we add one column, we add one row. We add one column, we add one row for each domain which we discover. So whenever we download a website, we first add a row with this content, and then we add a column and refer all the websites which this current website is referring to, and that's what we do. All right. So now you can understand what I'm saying. Yeah. All right. So this was the most important part. So whenever you are designing something, you always think about all these aspects. That first, and also the other thing which you noticed, must have noticed, is that we are using the column name itself as the row storage, as the data storage. So last time when I was actually this in one of the cases at InMobi, when we built this database using Cassandra. Cassandra has the similar architecture. In the row header, we were using a big text string, while in the column header, we were actually storing a MP3 file. Okay. Yes. Yes. So basically, the idea is whenever we are building something, we add more and more columns as and when we want. Okay. So as an exercise, we will be talking about an email storage. Think about what will be the column, what will be the column family, what will be the how what will happen whenever email arrives, how many columns will it create, will you put all the data of the email inside the column name itself, or will you put that into the row header? So those are the very fine decisions you need to take. So you will have to design your database keeping all of these things in mind. Okay. So again, a quick recap. First, the data in column families is stored together, and you can keep on adding as many columns as you want. Columns have columns can store anything in the column name. Row can store anything in the row name. Values can store cell can store multiple versions, and the data in rows is sorted by row ID, and so on. All right. This is the another way to look at it. Under each cell for this row key, timestamp T9, the value is this, while for this row key, timestamp T8, this particular column has this value, and so on. So timestamp, basically for different timestamp for each cell, will have different values automatically. Okay. So indexing is based on row key. Tables are sorted based on row key. Each region of the table. All right. So yeah. So our table is made up of rows, and further rows are split because of the reason. So some rows go into one region, some rows go into another, and one region is defined as start and end key. Okay, start row ID and row ID. From this row ID to this row ID, the data will go into the first region. From this row ID to that row ID, the data go into the second region, and so on. Okay. And everything in HBase table is stored as byte array, which means binary data. It does not have integer, string, and all those kind of data types. Okay. It has only one data type, that's byte. Alright. And atomicity is guaranteed at row level. This is another important aspect for the design. that it is guaranteed to when you are creating or writing or updating a row, all the values of a row will either get committed or nothing will get committed. It will never happen that some of the columns got changed but rest of the columns remain unchanged. Or while writing, while we are updating the row, the users will not see the intermediate changes. They will see only the final outcome, either nothing or all. So there is a transaction on per row basis, but you cannot have multi-row kind of transactions. You cannot have, say, update the first row, add these two rows in a single transaction. You can't do that. Okay, so whenever you are designing, that's another thing you should keep in mind. Okay. Also, another thing is column families have to be created upfront. To change column families is very big headache, meaning you might have to create another table and then copy the data there and delete from here. Okay. Column qualifiers are dynamic and can be defined at write time. They are stored as byte array, so you can put data in them. All data model operations return data in this sorted order. Okay. Row key, column family, column qualifier, timestamp, etc. Alright. So this will be the order in which you retrieve the data. Okay, again, tables are automatically split into regions, okay, based on rows. Each region is defined as starting of the row and ending of the row. Okay, and each region basically is a subset of total number of rows, continuous subset. And as you can always guess that region is identified by table name, first row inclusive and last row exclusive, meaning last row is not included in the region. Alright, although it is represented by last row, but it's exclusive, meaning last row is not part of this region. So what happens is that when you are putting data into HBase, when you're adding data into HBase, you will create a table, then you will put rows, and you will keep on adding rows. And initially there will be a single table, single region, and the moment the data keeps on growing, this table will split into two regions, equal half, and then one region will move to another machine, and one region will stay here. And as and when these regions, these two regions grow further, they will split into two equal halves and then get further divided. Now you can imagine that if the data is being uniformly distributed, initially there will be one region, then there will be two regions, then there will be four regions, then there will be 8 regions, and then there will be 16 regions, and so on. Okay, as the data is growing, the more uniform the data distribution is, the better it gets. Okay. Or even if the data is not uniform, still it's not too much of a problem to HBase. Imagine that we are just appending the data in an ordered manner. Okay, so first we will create one table, and then we will create another table. We'll create one table that will get split into region 1 and 2. Now first one is not being appended, only second one is being appended, and then second one after some time will break into two, 3 and 4, imagine. Now fourth one will keep on appending, but third one will not, if we are just doing a sequential addition to this data. So that way it will keep on doing split, and thereby making it possible to write to multiple regions simultaneously, and hence the load will be distributed to all the regions rather than a single region. Only in case of append only or sequential writings, say every time the row key is bigger than the previous one, and so on. In only those cases the traffic will not be traffic will not be properly distributed. But in most of the cases, when the next row key is not really in the sequential manner, every new row key is, or random. In all those cases, the traffic will be distributed amongst region servers. So how is this threshold defined? So the general threshold is, we make a guess that how many rows will make up a single HDFS block, 128 MB, and accordingly we design our limit. Okay, so we tend to keep one region per HDFS block. That's the design. All right. Now, Srinivas's question is, who will decide how many regions and partition stuff? So it is automatic. Okay, it is automatic. The only thing you need to decide is when the region server needs to split. Okay, imagine that your threshold limit is, say, close to some 1000 1 GB. Okay, or let's say your threshold limit is 1000 rows. Okay, the moment the table hits the 1000 rows, the table will be split into 500 rows each, and as and when these regions will grow further, they will be further broken into parts. All right. Now, HBase master will keep only this track, that starting of this row key, ending of this row key exists on this particular region server, and starting of the row key from here to here is on this region server, and so on. So whenever the user is requesting for a particular data, the HBase server will send the request to only those machines which have that particular range. Okay. Now, physically, this is how the data is stored. Let's have a look at it. Let's have a look at it. I'll just go into our data store. Alright, so you can see that these are our tables. Okay, these are our tables. Say there is a table called customer. So under the hood, this is how it's storing. So there is a table name, right? Then comes the reason. Okay, for each table there will be multiple reasons, and you can see the reason name is a ID generated automatically. And this reason contains the column family. Under the reason, the column family is like C1. This is what we have defined already. So customer name is something which we defined, and column name is something we defined, and under the column family is your store file. Okay, now you can see that why we were saying, so for each column family there is a single file containing all the data. Okay, so the data of all whole column family in a region is together. Okay. All right. So I hope this day this is, so general people's general question is, where do HDFS store the data? Sorry, where do HBase store the data? The answer is here in HDFS. All right. So we have talked about locking. Now scanners is all right. So do you want to take a break and then come back and then we discuss further? Okay. So we will be back by 8:52. Oh. All right, so should we start now? Okay, great. So, is whatever we have discussed till now, is that clear to everyone? All right. Okay. Okay. So, if there is a doubt, Basraj, which you think that this particular doubt is there, you can ask now so that we can discuss that part. Okay. Oh, that's a problem. Okay. Yeah, that's actually the problem. If there are doubts, then you can discuss. Correct. All right. So far we have discussed is that there was why do we need no SQLs, what is their limitations in terms of cap theorem, then we discussed in terms of HBase, and then we discussed the data model in HBase, then we discussed reasons. Okay, so you can the other way you can have is reasons like this. Okay, all right. So in case of region servers, the other way you can look at it, imagine that your row IDs are from A to Z. Okay? So region server 1 will have one region, or it could have another region, like from A to C, from keys T to Z, and another region server might have keys from I to M and M to T. Alright? And region server 3 might have the keys from F to I and C to F. Alright? Also the scanners, HBase scanners, when we query HBase database, we create something called scanner. And scanner is basically it scans through the database table. Unlike unlike our RDBMS, where scanning is considered as one of the worst thing that could happen to a database design, here in HBase, scanning is the very frequent operation. So whenever we have to get the data, we basically create a scanner and scan the data. And when we are saying the creating a scanner, we are essentially saying that here this is my starting row, this is my ending row, these are the column names. Column name, whenever I say column name, it is composed of two things: column family and column qualifier. So a column is basically identified by these two things. So whenever we are defining a scanner, we are saying start scanning the data from this row till this row, and these are the columns to return, and we can optionally give a filter that wherever this condition is matching, give me only those rows out of start and stop. Okay, out of the selection, give me only these rows. Also, scanner is similar to cursor. The way cursor have give you a single window, and if you want to retrieve more data, you have to tell cursor to get more data, and and so on. So scanner basically will start getting you the data from the first region server, and the moment it hits the boundary of the region server, then you'll have to again call next to, and this next will go to another region server and then get you the data. Okay, so basically next is what do you call makes a trip to the data server. Okay, and in the by default it will give you the records whatever available on a single region and lying in this particular range. Okay, so that's a scanner, and that is how you basically scan the database. Now please note that in HBase we do not have a query language, so that is why we generally call HBase as data store. HBase does not have a query language. Instead, HBase gives us the scanner kind of a model where we can scan the data, and this is, you can see, it's pretty fairly basic. Okay, and all right. Again, yes, Kalyan, go ahead. This is the architecture which we have discussed. So, yeah. So there is master, then all of these people are storing the data into HDFS. There is master, and then there are region servers. Region servers are informing Zookeeper cluster, and master is reading from Zookeeper cluster, and so on. Okay. Now this is a little bit of a hands-on demo. We can give you that. Region servers are similar to what you call as data nodes. Okay, data nodes are part of HDFS, and they are similar to data nodes. And in that, you can imagine that there is a new kind of completely new system. Okay, and so yeah, let me answer Basuraj's question. Region servers are nothing but data nodes. No, region servers are region servers. Just that everybody is storing into HDFS that might be having name node and data nodes. Yeah. Is it? The voice is breaking for all.